Okay, I'm going to take you on a walkthrough of the ChiliPeppr Cayenn devices. I've got three devices here, a laser 3 amp, laser 5 amp, and an air coolant. This one's being used for my UV laser. This is for a blue high powered. And I've got this set up connected to a TinyG. You'll notice that there is a wire coming out of the coolant on-off pin going into one of the Cayenn devices. Internally, that's linked to the other ones. This is the synchronization signal from the CNC controller. Although I'm using a TinyG, I could actually be using any CNC controller because it's just using the coolant pin. And so inside ChiliPeppr, you'll notice that there's this new Cayenn devices feature, and I already have it open here, but notice when I hit refresh, I get three devices. And you also see that these blue lights change as it's requesting discovery. It sends out a broadcast command, and then the Cayenn device reports its name and its icon back, and ChiliPeppr picks it up. So let's go into the air coolant, and you'll notice it's got a bunch of commands, but one of them is air on. So when I click it, it actually turns on these relays, which turns on the air compressor and some cooling fans. Likewise, if I go over to the laser UV, I can click on this PWM faint. Now notice nothing turns on, so I'll turn that off. You actually have to do a laser boot, and the driver powers up, and then you can do your PWM command, which is so faint you can't even see it. So let's turn that one off, and I'll go over to the laser 6 watt. Same deal, that's got a laser boot command. So notice the lights go, the relay goes, and then it takes about 5 seconds for this driver. There we go, you see the LED turn on, and then I'll turn on this little PWM faint. The reason I use faint a lot is if I'm trying to get a focus point, I want the lowest power setting possible to get a focal point. So let's go ahead and actually run a job now that we're kind of seeing how all these devices work. I have a Gcode file prepared that has all three commands synchronizing to it. So I'll drag that into ChiliPeppr. And notice as you're doing it, there's an upload happening where it's uploading to each device. And what it's actually doing is counting up all the commands, and it's looking for an ID. So ID 0, ID 21, ID 1, ID 3. Those correspond to the coolant on-off high-low values. When the job starts, the coolant pin is indicating that ID. And so if I zoom into laser 6 watt and I look at its queue, you'll notice that it's got ID 2, ID 4, and so on. And then if I go over to, for instance, air coolant, it just has an on and an off. So it's got the first command at 0, it's got the next command at 21, and then the laser UV's got some of its own commands. So let's go ahead and run the job. So notice the lasers, I've turned the air compressor off so it's quieter, but notice that the laser here gets turned on, and then the UV turns on, and then the UV turns on there. And what it's essentially doing is cutting out circles with different laser values as it plays the Gcode. The fans are running, and then at the end of the job, everything will shut off, perfectly synchronized, and ready to go again. And so just to try that one more time, we'll go ahead and we'll actually watch one of these logs as we're doing it. We'll hit play. It resets all the counters so that the coolant on-off pin can synchronize correctly on the next play. So we're waiting for the lasers to boot, and once the Gcode starts playing, you'll see it's doing the first circle, now it's doing the second. And I want to point out that these lasers are perfectly synchronized during the Gcode. They're not waiting for any sort of millisecond delay because they're reading the coolant on-off pin, which is exactly synchronized to the hardware. And so the fact that you're pre-uploading the commands and then you're playing the Gcode makes it really robust. So let's zoom in a little bit and look at some of these features. What I've got inside are some NodeMCUs, and there's 4 WS2812B LED strips so that you get those indicators. Those have actually I initially just wanted to do it because it was kind of cool, but it's actually turned out to be really useful for debug. And for the air coolant, you simply are controlling 2 relays. I went with relays because I'm doing 120 volts. I'm doing a relay also on the 12 volt. I didn't need that. I could have done a MOSFET, but I actually kind of like the clicking sound. This is a 5 amp driver. The TTL is actually connected to the NodeMCU. The power is going through an ACS712 current sensor, because this also will send back current readings, so I could do a chart inside ChiliPeppr, and then this NodeMCU is driving this 3 amp laser driver. That power is going through an INA219 current sensor. It's lower amperage, so we could do that. Both of these have relays to control sort of the global power to the laser driver. These things actually always are sending current, and so I wanted to do sort of a global on-off. You'll notice too that this is this setup should actually fit onto this 5 1/4 inch sled, which slides into this PC. It's just an old computer, but it fits nicely inside, so that I could fit sort of 9 devices in here. I could fit some more on the inside bay, but I'm also then using the power just off the old PC. So that's kind of the whole walkthrough. I power these. These are just for power, but when I actually have to program them, it's pretty handy to be able to connect them as well. But you do not actually need those connected once they're programmed, because everything just runs over Wi-Fi.
I want to describe to you what's going on in the Gcode here. And these are the first lines right here that show Cayenn Gcode commands. And so notice that these 3 lines are specifying a Cayenn device, and the value here is air coolant, laser UV, laser 6 watt. And this is just JSON. And then these are startup commands, air on, laser boot, laser boot. Then there's a pause after. That's an extra value that the Cayenn parser supports, because what it's actually doing is converting these lines. When you drag and drop it, it's converting them to M8, M9. So when I say convert, you'll notice that this is the original comment, but it adds the M8, which makes the coolant pin go high, and then it adds the M9 to bring it back to low. The next command gets its own M8 so that it goes high and then low. And when I say convert, notice that the P1 is a pause of 1 second, because the pause after was a 1, and on this one there was a pause after of 3. The reason that this is needed is that it takes a few seconds for these laser drivers to turn on before they're active, and so you really do kind of need a pause. It would be pretty cool to actually do the reverse, where TinyG waited on like a power good signal. That's not really doable today on TinyG, at least the V8. The G2 looks like it's going to allow that. And then these are the next ones where it's just making sure that the PWM's off, so it's just sort of a redundant or sort of like a safety net. And notice that those right here convert. You see how the ID is 3 and ID is 4? That's the other thing that's getting added, is IDs get added. But when you're writing your Gcode, you don't have to worry about that. You simply just add an active JSON comment where you're specifying the device. The only last thing I'll point out is that the last Cayenn device is then what's assumed in subsequent statements. Kind of like when you specify a G0 or a G1 move, subsequent lines, you don't have to always re-specify that value. And then notice here, for instance, it's PWM off, and then I'm switching to a different laser. There's actually like a hertz and a duty value that's really up to you and how you implement your device. So for instance, if you were doing a dispenser, you could have your own parameters, or if you were doing, say, Frank Herman's XATC automatic tool changer, you could, specify all sorts of different values. It's just plain old basic JSON. And then at the end, you're turning off your laser, and then you're sort of doing the shutdown sequence.
One other thing that's worth showing here is how I program these. I use the NodeMCU space in ChiliPeppr, and on the device, for instance, you connect over here in serial port JSON server, but then over here you use that reset button a fair amount, but you get all of your output. So for instance, if I want to see how much memory is left, I can say node.heap. If I want to, this is the main file that gets loaded right here. And so it loads 5 sub-libraries. Those are pretty reusable. So for instance, on the 6-watt laser, it's the same libraries being used other than the laser driver itself is the specific piece. And on this one, the relay driver. So for instance, while this is running, I can say relay on. Oops. And for instance, you can hear the coolant turn on, that air compressor. The way it's set up is that you tell it the name of the device, the description of the icon, that's returned into the UI. You tell what commands are available. Those end up showing up in, they end up showing up here in this list. So air on, air off does the same thing, and you can kind of see the results. All of this communications over Wi-Fi. You do have to have serial port JSON server 1.93 running, which is only available in GitHub. It is not available as binaries yet. The on CNC counter is what gets, it's a callback so that as that coolant pin goes high, this gets called and then the coolant pin goes low to sort of reset itself. It's pretty well debugged with debounce to make sure that it's accurate. And then this on command is when things come in that are commands like air on, air off, reset counter, get counter, get the queue, wipe the queue. So for instance, when you come over here and you say get queue, it's actually calling this method right here. And it's just kind of a big tree of commands, and that's about it. Other than these sub-libraries that become pretty important. There is a queue that's actually stored on the SD card, so you'll notice there's this queue.txt. And so for instance, if I want to go ahead, let's see if this works, dump out that queue. No, I don't have enough memory to view it. Let's try it from this way. We'll do a quick reset. That it lets you, let's try and dump it out really quick. Now you sort of start running low on memory once you're running it. But this is a pretty nice workspace to use, and all of this code, at least for the UV laser, is already up on GitHub. I'll get more of this up later. So this is the way to program your NodeMCU devices pretty darn easily.